Okay, so we're going to solve some equations, and what all of these equations have in common is that the variable we're trying to solve for is in the exponent. So these are all examples of exponential equations. Okay, so the problem with solving exponential equations, these types of equations, is that I can't, if I divide by 4, for example, in the first problem, well, that's not really going to help me, because that's not going to do anything for my exponent. What I've got to do is I've got to be really creative in these problems. Now I've got to see if I can find any way for the two sides of the equation to almost mirror each other. And the best way to do that is to find some common bases. If I can make the two sides of the equation share a common base, then the problem actually becomes much easier and becomes more of a logic problem than knowing any tricks in math. So, for example, 4 to the x minus 3 power is equal to, well, 64 can be rewritten in a base of 4. I know that 64 is just 4 cubed, so I can take that side and make it equal 4 cubed. Now, those two sides of the equation almost look identical to each other, the big difference being in the exponents. So since the bases are the same, I can assure that the two sides of the equation will be the same if the exponents are equal to each other. So essentially what I've done is, once I've made those bases the same, I've said let's forget about the bases, let's pay attention only to the exponents. So now I have x minus 3 equal 3, solve for x equals 6 by adding 3 to both sides. So if I go up and check that, up in the original, 4 to the 6 minus 3, well, that's 4 to the third power, which is 64. That does equal 64. So the key here is making the bases common. Okay? So moving over to this problem here, 2 to the 2x minus 7 equals 1 over 8. Sometimes it looks difficult to make those bases common. However, as soon as I see a fraction, I should be realizing, oh, that's got to be a negative exponent. Because if you remember, negative exponents told us that we needed to flip the base. And 8 is 2 cubed, so 1 over 8 is actually the same thing as 2 to the negative 3 power. Negative because of the fraction, and 3 because 2 cubed is an 8. So now again the bases are the same. I can just focus on the exponents. I need 2x minus 7 equal negative 3. So I'll add 7. I'll divide by 2. So my solution is x equals 2. Okay, now with 5 to the 6 plus 2, 6x plus 2 equals 1. Okay, similar idea here. That 1 is tricky unless I remember that anything to the 0 power is 1. So I can rewrite that as 5 to the 0 power. And now I have 6x plus 2 equals 0, 6x equals negative 2, and x equals negative 1 over 3. Of course, last but not least, now this last problem, it's silly to make this more difficult than it needs to be. The bases are already the same, so I can jump right to just setting the exponents equal to each other. Add x to the other side, add 4 to the other side, divide by 3, x equals 2.